Start section 3, or continue it, I guess, from yesterday. I'm on 536 in your book. Using momentum conservation. The law of momentum conservation can be used to predict the velocity of objects after they collide. To use the law of conservation of momentum, assume that the total momentum of the colliding objects doesn't change. For example, imagine being on skates when someone throws a backpack to you. The law of conservation of momentum can be used to find your velocity after you catch the backpack. Suppose a 2 kilogram backpack initially has a velocity of 5 meters per second east. Your mass is 48 kilograms, and initially you're at rest. Then the total initial momentum is, you've got your total momentum, which is your momentum of the backpack, plus your momentum. So 2 kilograms times 5 meters per second east plus 48 kilograms times 0 meters per second. So we come up with an answer of 10 kilograms times meters per second east. After the collision, the total momentum remains the same, and only one object is moving. Its mass is the sum of your mass and the mass of your backpack. You can use the equation for momentum to find the final velocity. Mass of the backpack plus your mass times velocity. I'm on page 536. No, you're not. Close it. 10 kilograms times meters per second east would equal 2 kilograms plus 48 kilograms times velocity. 10 kilograms times meters per second east equals 50 kilograms times velocity. So your velocity is going to be 0.2 meters per second east. This is how your velocity right after you catch the backpack. The velocity of you and the backpack together is much smaller than the initial velocity of the backpack. Next page. Colliding and bouncing off. In some collisions, the objects involved, like the bumper cars, bounce off each other. The law of conservation of momentum can be used to determine how these objects move after they collide. For example, suppose two identical objects moving with the same speed collide, head-on, and bounce off. Before the collision, the momentum of each object is the same, but in opposite direction. So the total momentum before the collision is 0. If the momentum is conserved, the total momentum after the collision must also be what? 0. So the same before and after. This means that the two objects must move in opposite directions with the same speed after the collision. All right, we're going to do the section 3 worksheet today. I am going to work, I believe it's number 7 for you. I'm going to pause the video, get everybody their worksheet, and then we'll work on number 7 together.